Yeah, basically. I know, that's honest, right? May as well be honest. Life's too short not to be honest. Well, careful. If everybody lives by that, let's be honest, there could be some really mean things said. So let's be honest with grace, right? Speak the truth in love, right? Especially in high school. Coming back, it's in all of life. It's not just high school. It's not just you guys. But coming back, so speak the truth, but in love, please. But coming back, I'll try to do the same, and if I ever don't, let me know. Maybe not in front of people, maybe on the side. But why was I showing you the derivative of sine inverse? First of all, what is the derivative rule for sine inverse of u? 1 over the square root of? Yeah, 1 minus u squared times u prime. What if I was to put a quick little 1/3? Can you guys add a 1/3 in your example? If there was a 1/3, just a constant, no big deal, wouldn't there be a 3 down here? Or a 1/3 like in front? Yeah? How would that make any difference? The u prime wouldn't have stayed? Why on earth did I show you this? Right after we crossed off all of our nice u sub that wasn't going anywhere. Who was in the integral? Isn't it just this guy? How is this going to be a tricky section? What was the answer to this antiderivative problem up here, kiddos? 1/3 arc sine or sine inverse of u, who is the guy who's been squared, 3x over a, who is the guy who's been squared, 1 plus c. Can I zoom in on this real fast? What was I trying to show you by having these two examples at the beginning of section 4.7? It's okay. Keep pondering it just for a second. I'm going to keep solving this because we got to yesterday like, oh, we could solve it. We just didn't actually solve it. Unless it's mine. I think my sound's off. It might not be. I'm sorry. That's someone else. Is my sound off? Ah, look, guys, how's that responsible today? Anyway, isn't this negative 1/4? How similar are the integrands? What are integrands? Right? How similar? Very. How similar are the answers? Who does this guy end up needing and using? Power rule. Who does this guy end up needing and using? Arc trig. So what am I trying to warn you of? Be ready. Yeah. Yeah. Does that kind of make sense? At least the warning. The reason why arc trig is so tricky, and the reason why we're just going to practice, and the reason why I wanted you to get your forever card down right away, is that some of you guys are like, okay, it's easy, I get it. Whenever you have a 1 over root. Nope, not just a 1 over root. Oh. Whenever you have 1 over something with squareds, minus or plus with a root or not with a root. Okay. But can't we sometimes have like a du that won't look like a du at the beginning, and maybe there will be x's on top that need inverse trig also? And maybe I'm saying too many things that you guys don't have enough experience to realize what I'm saying. So I'm just going to pause here. I'm going to time out here. But you at least see the dilemma in these two beginning problems, right? This leads one way. This leads another. What was key? Whether or not the u sub, the traditional u sub, the either choose the whole denominator or what's inside something in the denominator, whether or not the u sub was going a nice way, that was getting closer to a direct rule, or a bad way, where it's like, oh, I need to recalibrate my thinking. I need to adjust my plan. I need to think about this another way. All right, cool kids, with that, let's pause real quick. Let's go check or grade section 4.6, right? Color pens out really quickly. Homework spirals open. We need to grade the evens on 4.6. I think I took just a couple questions on 4.6 yesterday. Oh, no, we probably didn't have time. That might have been period 6. I don't remember. But we didn't grade yesterday for sure, because remember the whole 50% thing, and then have it done by today, and yada, yada, yada. You guys did get your test back whether yesterday or today, so we do need to put chapter 4A corrections on the board. If you guys remember, we do have a test coming next week. Has anybody checked out the calendar? I think the Forever quiz is on Tuesday, the day we get back from the 3-day weekend. But the nice thing is, guys, have you realized how many Forever cards we have this chapter, or this part of the chapter? I think it's like 3. I think 2 or 3. Because the first one, we didn't have a card for you, Seb, right? I don't think we did. We had a card for all the LN stuff. We had a card for the E to the U, B to the U, and we have a card for inverse trig. All it is derivative rules. Should this be like a, I'm going to ace it and get the bonus? Yeah, it should. Okay, so come on. We got this. Just don't forget it. Maybe put a reminder in your phone right now, like for Monday night. Study your forevers, okay? So anyway, all that to say, Forever quiz is Tuesday. I think our test is Wednesday, so I'm going to make corrections due Thursday, which is a week from today. Does that sound good? That sound fair? Okay. That way, I mean, if you get them done this weekend, that's awesome. If you get them done the next couple of days, that's awesome. You can go put them in your test correction folder up at the front. Oh, that's very buried. I need to work on... Ugh. Sorry, guys. Don't look at my lack of organization. Although some of your rooms, you're way worse than I am. Anyway, it's true. And with things way worse than papers, too. Ugh. Do your laundry. Anyway, so coming back. Just kidding. Kind of. Let's go ahead and grade section 4.6, but I wanted you guys also to know corrections aren't due until next week after the test. Remember the Forever quiz coming and the test coming. And to let you at least hopefully take a quick peek about how section 4.7 is supposed to be due tomorrow. All right. You guys already get number 2, number 18, number 26. Number 18? Well, how'd they go from here to here? How'd they go from there to there? Improper fraction, they divided. Booyah. Then they said, I know you, I know you, I know you. Uh-oh, you sub. But u is x plus 5, du is just 1 dx, so there's no need to offset by a constant or anything crazy. Number 26, you guys had a few options. Are they showing their u sub? No. Did anybody think to do it their way on 26? Their way, my brain gets it, but I don't think most of you would have thought of doing it that way. But did your way work out? Uh-oh, it didn't. Okay, no, that's really good. Because their way is funny. And some of you are like, I'm just copying their way and I'm hoping I'll understand it someday. Don't do that. There's another way of doing this. Someone tell me how you approach 26. Because they were weird. Like, we did, and then they, what did they, okay. What did you do? Yeah, I think that's what I would have done too, right? U equals x minus 1. So x equals u plus 1, right? I would have done that later, but hopefully eventually. Du is equal to dx. So then hopefully you guys would have plugged in and gotten a u cubed. That's where you got this guy from, true? And then a du. Did anybody then try to plug in u plus 1 for the x? And then u plus 1 minus 2 would be u minus 1, right? Okay. And then did you FOIL it and get u squared minus 1 after first outer inner last? Outer inner cancel, all over u cubed. What'd you do next? I like it. This is good. Did you rewrite it? Whether, oh, sorry, your class likes u to the negative 3. Okay. Is this okay? And then when we distribute, don't we get 1 minus a u to the negative 3? Are we okay? Guess what? A u to the negative 1 and a u to the negative 3. Whatever mumbo jumbo they did, we got there. It's okay. Yeah? U to the negative 3, integral. Can't we integrate that by adding 1 so we get u to the negative 2? You guys okay if I put it down there? U to the negative 2 divided by negative 2. Oh, wait, a negative will be a positive, 2. No, divided by 2. Sorry. I'm running out of space, so I'm trying to squish. But add 1, negative 2, and then divided by negative 2. So negative 1/2 times a negative positive 1/2. Got it. But why am I going to do ln of u? I thought this was power rule. Good. If you add it, it's 0 divided by 0, trouble. Oh, that's right. That's not power rule. 1 over u goes to ln, right? Pussy. Last thing you have to do is, who are you? Well, That's incorrect, right? Who is you? As in you, not as in you, as in you. Anyway, so plug it in, and I think we're done. I think we're good. So are we okay with how to do it our way? Okay, okay. Remember, you don't have to do it their way. Sorry, 3256. Guys, even though there are only 3 forever cards this chapter, there are some really tricky rules that a lot of Calc BC kids off top of their head wouldn't remember right now, even though this is their second year of calculus. Integral of tangent, they'd be like, it's an ln something. So we got to get those down. We got to get them memorized, or else the AP loves to throw random. What test was it? Was it the last test? When I threw like just a random trig rule, integral, like a, did you guys get the cosecant, cotangent one, or did you get the, I threw a random rule. Why? Because it's easy, it's fast, and you either know it or you don't. The AP does that. Not every question, it'll probably be 1 or 2, but still, what if they throw you, what if they lob you an easy one, and you're like, oh, I didn't memorize my forever card. Memorize your forever cards. Good? Good. Ooh, nasty, 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 but 1 minus 2 ln of 2 is good. Ooh, did anybody rewrite this? How could you rewrite this? Yeah, you could do a 2 squared, so you could do 1 minus ln of 4, or I guess you could do 1 plus ln of 1/4. Oh, they wouldn't have done that. Nah, 1 minus ln of 4. Anyway, another way of writing it. Do you have any more? 106 is A. 108 is long. 106 is A, then let me zoom in. As I zoom in, let you grade. Is 108 our last even, guys? Okay. Ooh, can I even fit it all? Let me try to full screen. Is that any better? 0.2256, that's the final answer. For letter C, for letter B, I guess I can move it this way a little bit, huh? Okay, for letter C, 0.2256 is your final answer, or you can look at this expression and see if you can make it match. Letter B, remember, you didn't have to get the decimal. Letter B, blah, 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 blah. It's just the integral from 0 to pi over 4 of the blah is the expression that would find the area. They did not tell you to solve it, which is pretty nice. And then for letter A, they were asking for the equation of the tangent line. So you had to, actually, guys, you could have stopped right here. I'm going to put my cursor. Remember, you didn't have to get y by itself. I know they did, but you could have just stopped right here. You needed the derivative and then plugging in. Then you needed the x1 and the y1. Okay. I have my book open. It's ready to go. Any odds? Yeah, Ali. 29. Don't worry. I'll come back to evens in a second. Any other odds besides 29? Yeah, AJ. I'm just getting pictures of it really quickly. So 29 and 21. Why are you all crooked? Maybe it's because this is crooked. That's okay. Okay, anything else besides 21 and 29? 37? All right, last call for odds. Anything else? Call it out for odds. I have 21. I have 29. I'm about to get 37. Oh, 37's up here. Just kidding. Oops, wrong way. Who likes what, where? Okay, any more odds? Call it out, call it out. Don't worry about the hand raised. We're good? Okay. Evens. We'll get to in a second. Let's do odds first. I know, I'm a little bit mean. Okay, it's nasty, but here we go. Zoop, zoop. 21, what'd you guys do? What were the directions on number 21? Oh, I'm in section 4.7. I was like, why is this in section 4.6? Why is all my... Oh, you guys, I just stole all the wrong problems. Okay, hold on. Lo siento, lo siento, lo siento. Hopefully you were all super confused when I pulled that up, right? Yeah. Hey, for number 21, can you guys look at the front board? Yesterday, someone in period 6 said, when on earth, I think it was Melanie Tadros, she was like, when on earth or would you ever make you the numerator instead of the denominator? Do you guys see that problem on the front board? When on earth would you make u the numerator instead of the denominator? Look at number 21 and try to think about why I'm bringing that problem on the board up right now. What do they both have? An ln. And who's harder, an ln or just like a little baby x or u in the denominator? Ln. Why? This might be a trick. Not a trick. This might be a very important note to make. Guys, do any of our integration rules have an ln inside the integral? You just did an entire section on the natural logarithmic function, but do any of our rules, any of them, the entire forever card, have an ln inside the integral? No. The only way to integrate ln of x is using a CalcBC formula called integration by parts that we're not going to learn. So, if we can't integrate ln, I think I'm going to make him u because I'm really hoping that I don't have to actually integrate him and I can just make him u and it's u squared. Huh? But what would du be if I made u the ln? Doesn't that mean that dx would equal x du? Oh, so it's u squared all over x times x du? Isn't that kind of the exact same thing that happened up there? We don't mind ln as long as we make him u. We don't mind ln as long as we make him u. So long story short, you end up with the integral of u squared du, which would be 1/3 who cubed plus c? Ln of u. Sorry, no, my bad, ln of x. No absolute value because there wasn't one to begin with, and I'm just plugging in. Dun, 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 dun. Wait! Can't we bring up the 3 and have it cancel? Sorry, or the 1/3? No. Did you guys see what I was trying to show them yesterday about why they couldn't or why we couldn't bring up the 1/2? It'd be 1/2 times, think of it mathematically, times ln times ln. This 1/2 can only go up to one of them, not. So I know that's a little tricky, but the same thing applies here. We could write ln of x, ln of x, ln of x, and bring up the 1/3 for one of them, but not for all of them, which means he can't cancel out the 3. It was indefinite, and we're done, right? Sweet. What did you guys naturally think number 29's u was? Is that okay, the whole denominator? Did you guys hopefully think of this being to the 1/2 power, bring down the 1/2, negative 1/2, we have something like this? Is that good? So then we have 2 root x du is equal to dx to go plug it in. So we end up with, it's okay, just where you got your u from, make it u, plug in who's left. If we have extra stuff, what do we go doing? Yeah, good. Do I even need to get x by itself, or can I just plug him in? Yeah, so I can go ahead and say, okay, I'm going to have 2 times, well, there's 2 of them. I mean, it's squared, so I can plug in u plus 3. Can we deal with this, yes or no? Yes, I'm not going to show all. Pull the 2 out. U squared plus 6u plus 9, all over u, all over u, all over u, du. You guys see what we're doing? That would end up being 1u, which would be a 1/2 u squared with a 2 in front. That would end up being a 6, so that would be a 6u when you integrate anti-derive. That would be a 9 over u, which will be 9 ln of absolute value of u. The plus c times 2 can kind of just come out and be a new plus c. Guys, all you got to do is come back and plug in your u. Done. Is that okay? Check it in the back. It's an odd. You can look at it on CalcChat as far as how to simplify, how to rewrite, but that's the big idea. Rebecca, I'm sorry. Were you the one that had the other question? There was one other odd. It was 30, 40. Who asked it? Somebody asked it. Oh, yours. Yeah. Which one was it? Okay. I heard it just from right in there somewhere. 37. 37's up here. Ooh. It's a tricky one. What do you guys think your u should be? Yeah, I agree. 1 plus sign. We almost always go for the denominator. One of the weird exceptions is ln. Another weird exception is if we were to see an inverse trig inside, not coming out, but inside, we would make that a u. But usually we go for that denominator. So the nice thing about if we make the denominator my u, don't we just have cosine of t dt? So dt, doesn't that cosine or won't that cosine when we go to plug it in? Won't those cancel out? So I'm going to end up with 1 over u du ln of, throw in that 1 plus sign. But here's the weird thing, guys, and some of you are like, what's the big deal? To make it match, why would they say no absolute value bars are necessary? Now pause, hold on. Someone yesterday in period 6 asked a great question. They're like, well, does it really matter if you put the absolute value bars even if they're redundant? Thank you, man. If you put the absolute value bars if they're actually redundant? No, right? You can write things that aren't simplified and long answers, but what am I worried about? If you can make it match, right? So here's what the AP loves to do. You listening? The AP loves to have answers with some absolute values that have a mistake in them. And then a couple answers without absolute values, and one of them is right. But then they usually also have a none of these. Oh, crud. So then if I think I have to have the absolute value and I can't have taken it away, I would select the none of these, or I would select one of the answers a little bit wrong, not trusting my own work because I think the absolute value has to stay there. Do you hear what I'm saying? I don't want you to get tricked by whether or not there should be an absolute value. Sometimes it has to stay, and sometimes it gets to go. Why does this one get to go? Did you get it? Sign only goes between 1 and negative 1. Will this ever take away enough to make this whole thing negative? No. The smallest it can be is negative 1, which makes this 0, which doesn't exist anyway. I can't go any lower than 0 with this expression. Haha. Parentheses. Okay. With that, real quick, any evens? Any evens? AJ? 56. Any other evens? 18. Let's peek really quickly just because I have some of the work shown here and we can kind of like build off of what they did. On 18, AJ, did you divide first, kid? Okay. So I'm going to go ahead and say if you divide first, long division. Do you have any questions about long division? Except, careful. What would you guys warn anyone who forgot to do long division before they go do it of not making a mistake on? Probably a 0x squared. And also, do you remember in division how we have to subtract whole expressions? Could it be really easy to make like a killing the seal distribution mistake? So watch out for both of those things. But then, AJ, I think you would get to this solution, or you should. I think you should get to this solution. Wait. Where does this fraction come from, everybody? A remainder. And remainders, it would be a remainder of negative 115. Remember, we always put remainders over the denominator. And then at this point, just remember we can take the integral piece by piece. Ooh, careful the u sub for him. We can take him separately. U equals du equals, we'll get to negative 115 ln of. Is that okay? Okay, but yeah, I would make a note in like a colored pen or something, especially studying for the test, etc. Watch out for, maybe even in your notes, watch out for improper fractions. You can always do what first? Divide. But hold on real quick. You guys haven't seen many of these. You might also want to make a note with improper fractions. Improper fractions are when the degree of the top is greater than the degree of the bottom or equal to. So if I had a cubed over a cubed or a squared over a squared or a linear over a linear, you should also divide. Okay, and then number 56. Oops, I just passed it. Oh, I'm sorry. 56. Oh, okay, I like it. Guys, what's true about the degree of 56? Aren't they tied? Real life example of what I was just talking about. How on earth did they get here? This is not that. Oh, it might be that. If we, what? Just 1? Yeah, just 1. 1 times x is x. We can do x plus 1. What happens when we subtract? Negative 1 minus 1 is negative 2. Oh, so we have plus negative 2 all over x plus 1. Does this make the integral easier? Yeah, because that's just x. And this is just, okay, well, we should do technically, just to be safe, a little u sub over here. But if you guys notice, it just ends up being negative 2 over u du. Sweet. Sweet. Done. Well, who would actually get the decimal mental math, but done. But was there another way? Real quick, I just need to know from you, did any of you guys do u sub without dividing? Yeah. Was it possible? Uh-oh. You didn't get it. I think it actually could work. So hold on, Rachel. Actually, you and me, then for anyone else, because right now, if people did divide, good job. How many people just got stuck on this one and weren't sure what to do? Oh, okay. That's much more honest. Thank you, thank you, thank you. Here I was like, oh, wow, you all divided. Anyway, wouldn't you guys have made u equal to x plus 1? Just like this? And gotten du to equal dx? If you hadn't divided. I know. But if you hadn't divided and you would have gone to plug, wouldn't we have done over u du and then been like, aw, stink about the top? What do we do when we see aw, stink? Go get x. So x is equal to u minus 1. So wouldn't you have plugged in u minus 1 minus 1, u minus 2? Then wouldn't you have divided? Whatever, made it to the negative 1 power and distributed? We just think so differently. 1 minus, wait, what do you notice? Well, yeah, I'm kind of being lazy. For x within 0 to 1. This one time I'm just going to leave it in x's because I'm too lazy to think about u's. Think about u, but not. So you would have gotten u minus 2 ln of u plus c. Oh, wait, definite integral. So then, Thomas, I would have still kept my x bounds from 0 to 1. Plugging in u, x plus 1 minus 2 ln of x plus 1 from 0 to 1. These are different, aren't they? Oh, is it not going to work? Try it. What's 1 plus 1? 2. What's 2 minus ln of 1 plus 1 is 2. Okay. And what's that minus 0 plus 1? 1 minus 2 ln of 1. 0. Better study that one a little bit. What's 2 minus 1? It works out. Just have a little faith. It works out. Just have a little faith. Do we need to go this way? No. Does this way work? Yes. Does that way work? Yes. But what can you do anytime the degree on the top is greater than or equal to? Divide. Are we good? All right, cool, kids. With that, if you have any further questions, come find me. Before school, after school, et cetera, et cetera, et cetera. You guys know what to do, and you know when I'm here for the most part. I'm getting this ready for period 6, I know, which is a long way away, but it helps me. But we're going back to section 4.7. 4.7. And you already have your, oh, did I miss one? Oh, that was the one that we don't know yet. All right, guys. I need you to be willing to do some funny math with me today, okay? I need you to be willing to do some funny math with me today. I'm not showing you too many triangles. I show it more in BC as to where the rules come from. But I'm just going to give you a little baby peek. I'm just going to give you a little baby peek. What rule is this? Isn't that a forever card? Didn't we have like A's and B's and weird things going on way back when? We had tons of weird things going on. Like, oh, if f of a is equal to b, and then we put in the a, and then we put in the b, and then we have to switch them, and then, That's a forever card. Derivatives, we've been there. The long story short of where all of the rules come from, which you will never have to show me why, but some of you, it helps when you see the why, at least a little bit. How would we take the derivative of cosine inverse of u? 1 over f prime, well, hold on, f is cosine, right? Well, I guess I should say f of u. Wouldn't f prime of u be sine of u? Right? So 1 over f prime, 1 over sine of who? U? No. We don't plug that guy in. We plug in O. So sine of cosine inverse of u. Well, how am I supposed to do? Whenever we see a trig function, do you guys remember from way back when? Cosine inverse of u is equal to, we could do this different ways. Let's just say y. Do you guys remember that what's in the cosine inverse is actually the ratio? And for cosine, it would be adjacent over hypotenuse. I know pre-cal is like, coming back. But whatever's inside the inverse, you're going from the ratio backwards. Cosine inverse of 1/2 is, x is 1/2. Pi over 3. You switch it, ratio, and this is the angle. So if, okay. If I was doing a right triangle, I could say y is the angle, and u, nope, it's cosiento, u over 1 is the, adjacent over the hypotenuse. We actually did some of this in pre-cal for a second. Cosine inverse of u over, and we can put anything over 1. The numerator would be the adjacent, the denominator would be the hypotenuse to my angle. Wait, guys, in a right triangle, can I use what's here to solve for what's missing? A squared plus b squared is c squared. So c squared minus b squared is a squared. So this guy is the square root of 1 minus u squared. Oh, thanks. Did I not put a negative? Thanks, Patricia. Gracias. So I have my adjacent. my hypotenuse. I've used Pythagorean theorem, bless you, to find my opposite. Wait, why am I finding opposite? Who do I want? Sine of, isn't this y? So couldn't I rewrite this -1 over sine of my triangle? Well, guys, who's sine of my triangle? Opposite over hypotenuse. So I can say, oh, well, actually, in terms of what I know, cosine inverse of u, I can say sine is equal to opposite over hypotenuse, which over 1 is just itself, right? So check it. I can come up here and say, oh, -1 over the square root of 1 minus u squared. Why is the derivative? Why is the derivative of any inverse trig some weird expression? Because technically we're going to a triangle and we're pulling out ratios and putting them in the right spots as following the derivative of the inverse formula. So when we're doing integrals, we're going to be given weird ratios that happen to fit nicely into triangles that can go backwards to the original function of an inverse trig. I kind of maybe showed you a peek at this last semester. Just kind of refreshing your memory, because triangles do get really useful in upper calculuses. Kind of Calc BC, but actually more like a college Calc 2, Calc 3. And this thing called trig sub, where you take an expression that looks very algebraic and relate it to a triangle. We won't go any deeper than this today. But anyway, all of this is to remind you, inverse trig gets to these weird fractions with usually radicals every now and then without a radical, because it's a squared plus b squared. It's some sort of tangent guy. So when we're doing integrals, we have to watch out for anything with a 1 over, but sometimes that 1 over is hidden. Now this 1 over is obvious. You guys have a forever card, right? Don't stress about the triangles unless you want to think about it with me. Don't stress about the triangles unless you want to think about it with me. Technically, we could kind of come off to the side and say, oh, hey, this could be some sort of like a 3 and an x, and then this would be like a square root of, okay, we could think about that, but don't worry, we don't have to. We're not in Calc 2 or Calc 3 in college. But what we can do is say, hey, I think one of my formulas matches this. Which formula matches this? 1 over. Looks pretty similar to me. What do you guys think? Yeah. Where does this go back to? Is arctan and tan inverse the same thing? Why did I use tan inverse? Because I don't have space. Okay. U over A plus C. It can be either one. Okay, so hold on. Who's my u? My du is just dx. Do I have to worry about my u being funny? No. So can I rewrite this to be 1 over a squared plus u squared du? Yeah, I can, which means what can I do? 1 over, who's a? 3. Tangent inverse or arctan, I don't care which one. Who's u? X over a. Who's a? Dun, 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 dun. maybe tomorrow just for the heck of it, I might show you the longer way of doing this where we actually use the derivative rule 1 over 1 squared, 1 squared plus x squared or 1 plus x squared, which is the one you memorized last semester. We could actually divide everything by 9. It could get really nasty because we could do like a whole divide by 9 and divide by 9 and divide by 9. But it would get pretty nasty pretty fast. And we could get a 1/9 all over a 1 plus x over 3 squared. And we could pull out the 1/9 and we could make x over 3 with a du of 1/3, which would multiply to be a 3. The 3 times the 1/9 would get the 1/3, and then it'd be 1 plus u squared, which is like the derivative rule, and that would be the u. Whew! Or we could just memorize the a squared plus u squared and not have to think about all that nasty creative math. Let's go with the latter instead of the former. So these ones are straightforward. Now, guys, we just did this top one, right? We just did him? Okay, let's put a little check mark on him and say, hey, just page before. Okay, how about the next one? Uh-oh. Uh-oh. Do you guys hear it? I hear it. There's some rain outside. All right, here we go. Who's you? Yeah, why is it 2x? Good. Who's my a then? Uh-huh. Who's my du? So can't I come over here and say, okay, let's pull out the 2. Let's put in the integral. Let's do 1 over square root of a squared minus u squared times du over 2. Hey, the 2's reduce. Because the 1/2 would come out, and then they would reduce. It's legal. Who does this match up with? Arcsine. Not all of you might know this, but the formula for arcsine isn't 1 over a. It's merely sine inverse, or arcsine. I'll do arcsine just for the heck of it. Of u over a, which will be 2x over 1. Oh, sorry. Well, I guess we could just write that as 2x. Thomas, what's up, bud? Except, what's different with arcsecant? Well, the problem is, when you guys are looking at the forever cards, it's a great question. When you're looking at the forever cards, you have to realize that for all of these, a's have to be constant terms. And then u's have to be variables. Does that make sense? You're welcome. A's have to be constants and, v's, u's need to be variable expressions. And that's actually super important because you're right, Thomas, these are super similar. So the one where constants are in front. Now some of you are like, pull out a -1. Yeah, but we can't pull a negative out of a square root. So factoring out a -1 doesn't help me. Still innately, with the expression underneath, if the constant term is positive and the variable term is negative, that's looking towards arcsine. If it's any of them, it could be like a just good old-fashioned u sub. And what else is different? There's a key other difference. We have to have a u in front for arcsecant. I know it's funny, I know it's weird, but the triangle would get us there also. Sorry guys, I just remembered I was supposed to be looking at these rules and seeing if there's an absolute value, especially for that secant one. I feel like there's an absolute value. Ooh, there is. Guys, you gotta change one quick little thing. It's one baby little thing on your forever card. I need to save this in the notes for next year. Absolute values around the u. Do you remember the derivative of arcsecant and arccosecant, which is the same thing but with a negative? The derivative of arcsecant was 1 over absolute value of u times the square root of u squared minus a squared. Just believe me, look at your derivative card later. That's why we did this little absolute value. He didn't have any in his derivative. Sorry, he didn't have any in his derivative. He didn't have any in his derivative. He has that absolute value guy in front for his derivative, so we throw it in his integrand. Sorry, that's a little weird. Thank you, thank you, thank you. I knew I had to change something. And Thomas, I really appreciate your question, even though you didn't know. It was a reminder it was. We got that one. So how about number 3? Hey, Thomas, you see it? There's no way this is inverse trig. There's a 3x in front. Wait, arcsecant has a u in front. Guys, who's your a? Do you see him? 2. A squared. Who's your u? 3x. Who's been squared? All right, du is equal to 3 dx. dx is equal to du over 3. Let's see if I can get us some more space, huh? If I go plugging in, can't I pull this 4 out? Integral of? Okay. Yeah, that does match perfectly. Cool. So I can put a u. Square root of u squared, yep, 3x times 3x is 9x squared, minus a squared. Do I have any problems with my du over 3? What can I do with that? Yeah, I can make it 4/3. Remember, keep that 3 down below. But does it match my yes or no? Yeah, it does. Now wait, hold on. The 4/3 is in the very front, right? So just be careful with rewriting. Isn't arcsecant 1 over a? So 1 over 2 times arcsecant or secant inverse of u, absolute value of 3x, all over a plus c. Now I could put parentheses around that plus c, but hopefully you guys are realizing when I pull the plus c kind of off on his own, the 4/3 could multiply by both, but 4/3 times a constant is a new arbitrary constant. But when I multiply to be 2. And guys, just a quick algebraic reminder. If you have an expression inside a secant, under a square root, inside any sort of trig, in an ln, an exponential, can you just randomly go playing with the numbers outside and inside? Heck no, tech no, right? Which half? Oh, because isn't secant inverse 1 over a, arcsecant of u over a? Check out your forever card. I should think it's 1 over a, right? Like arctangent. Arctangent and arcsecant have a 1 over a constant coefficient going on, whereas sine inverse does not. Once again, I could kind of show you that with, where's a sine inverse? Oh, actually, he's a nice sine inverse. He's just 1. That doesn't help. Nope, let's keep going. Sorry for sake of time. I won't show you why the rule is what it is. We need to get to the more hidden ones. Ah, stink. There are more hidden ones. Didn't we have u sub that was super straightforward and then u sub that was weird? All right. We have that for this too. No, this isn't inverse trig. There's no 1 over. If you made u t to the 4th plus 16, wouldn't du be 4t cubed? And we'd have some b in the denominators and stuff would just get nasty. And maybe some of you need to do that a few times accidentally to realize how bad it is. But kiddos, what if I was to make a equal to 4, u equal to t squared, oh, t squared squared, du is equal to 2t, oh, you see it? Maybe you do, maybe you don't. But when we go to plug in, I can have my t over u squared plus a squared, which addition is commutative. A squared plus u squared plus a squared. I'm good. T. That t does not cause a problem with my arctangent. He was actually necessary. So I do get 1 over after u sub, u squared plus a squared, so therefore 1 over a, which is 4, tangent inverse or arctan of u over a, t squared over 4. You see it? It was a little more hidden. There was a variable on top, but still inverse trig. I know. It's making it small. The next one, why is it more hidden? Ew, there's an x minus 2. Yeah, but it can still be a u. With a du that doesn't make too much mess. A is just 1. Well, that's kind of nice. So I can actually rewrite this to be 1 over a squared plus u squared du, which takes us back to 1 over a, which is 1. Tangent inverse of u over a, x minus 2. Why did I show you this one? To lead up to this one. There's no variable on top. But wait a minute, guys. Was this fully simplified? That was written weird. 1 plus an expression squared. Couldn't you have FOILed that out and combined like terms? Oh, no. So sometimes they're going to give us an expression that maybe could be rewritten differently. if we could just remember something called completing the square? Half of 6 is 3. 3 squared is 9. Throw in a 9 over here. Oh my goodness, look. That would have been impossible with u sub unless you saw it was really x minus 3 squared plus 4. Oh my goodness, it's tangent inverse. See you guys later. Complete the square is back. Some of you need to review Algebra 1. Number 4. Wasn't that a great ending to today? Good job, guys. So proud of you. Some of you can go tutor your younger siblings and be like, how do you complete the square again?